Myself, Dr. Chandrabhushan Triveni Prasad Pal, FDP Coordinator and Associate Professor in Chemical Engineering Department, SN Patel Institute of Technology and Research Center, Umrak Badoli, Surat. It is my privilege to introduce our esteemed speaker, Dr. Meghal Desai sir, who has graciously accepted our invitation to be with us today. Dr. Meghal Desai sir holds PhD from SVNIT Surat and MTech from IIT BHU Varanasi. With a distinguished career in education, he has served in various capacities at SVNIT Surat, Department of Chemical Engineering. First, as an assistant professor 2007 to 2019. Then, as an associate professor 2019 to 2023. And since December 2023 as a professor. He also took on the role of head of department from May 2022 to August 2023 and currently holds this position again since September 2024. Sir's research is widely recognized with over 40 plus published research articles in international journals, 6 patents, and 4 book chapters also. He has also actively contributed to the academic community, presenting his work at more than 28 international and 8 national conferences. In addition to his research, he has an impressive track record in thesis and dissertation supervision, having successfully supervised 7 PhD scholars with 3 more currently under his guidance and 11 MTech by research candidates. Dr. Desai sir is an active member of professional bodies like
Hello,
AICSC and hello, hello
hello.
sir. हाँ sir.
You were not audible initially. That's why. Ah, okay. So,
Uh,
shall I start?
yeah, yeah
Okay.
sir.
Thank you, Dr. Chandrapal and Dr. Nilesh. So, I'm here to present the work on extraction of valuable chemical compounds from biomass waste using emerging technologies. So, as I am from SVNIT Surat. So, initial talk will be devoted to initial portion will be devoted to why we need to go for utilizing the biomass waste. Then what are the emerging or new technologies that are available for the extraction purpose, and then combining all these aspects into a definite process development. Okay. So now this word green consumerism, everyone is aware about or may have an idea about green consumerism. It is basically consumption of the product or the services which are less, you can say, affecting the environment, or you can say less having less negative impact, less carbon footprint. So right now, if you visit any even grocery store, or you can say mall, you will find you can say a section wherein you may find the utilization of that organic food and all that. Okay, so basically the intention is to utilize the product or the services which have less impact or shrunken carbon footprint. Even it is useful based on the reasons that the chemicals that we are consuming, the antioxidants, the you can say aromas, if if they are synthesized, that is based on chemical synthesis outside the plant, then it may have a negative impact on the human health also. So instead of that, if we consume the natural product, or you can say phytochemicals, phyto means from the plant, then it is believed that they have soothing effect and no side effect, generally considered no side effect on the environment, sorry, on the human health. And they are eco-friendly also. Their extraction, their recovery is eco-friendly also. But it is not always the case. So that is the reason why I have highlighted one product that is called Devil's Claw. Because see, if we are going to extract like anything, then it may happen that our product may, our plant material may extinct. So when our focus is on, say, green consumerism, to consume a natural product, at the same time, it is wise to check, is there any other alternatives available for that particular material or not. So the next part, that is the mango fruit. Why I have come down to this, I will let you know in a slide or two. So mango, everyone knows that it's a seasonal fruit, summer fruit, and India is one of the major producer. You can see that it is around 40% of the mango of total, you can say, production, and it is around 18.5 10 to the power 6 time tons per year. Now when we are utilizing this mango fruit, it has waste also, the peels and the seeds. Peels, they are around 15 to 20 percentage, they contain the weight, while the seeds, they are having 20 to 60. That depends upon the type of the mango fruit that is being consumed. But along with the consumption of mango, there is a generation of waste. And if the industry, that is mango processing industry, is consuming the mango, that is for, say, mango pulp and other purposes, then you may have, say, proper utilization, or you can say discard of peels and seeds. But if it is, say, unorganized sectors like consumption by us at household level, then it's, you can say, collection is an issue. Okay, so what happens to it? Whatever waste that are generated, it is either sent for landfilling or utilized for animal feed, goes for anaerobic digestion or composting. So when you are utilizing, or you can say disposing waste by this method, then there are chances of greenhouse gas emissions. Landfilling, that means you require land. And if it is through anaerobic digestion or composting, then it turns out to be a low value product. So current trend is like, you take, make and dispose. It is called a linear economy. Okay. Now the same flow. If now we focus on the peels and seed and try to check what is present in it. So again, same flow, current trend, but the analysis says that the peels and seeds contain some valuable chemicals. So extractives, they are in the range of 5 to 10 percentage. Pectin is in the range of 20 to 35 percentage, and the rest, they are cellulose, lignin, protein, hemicellulose, so on and so forth. So if I focus on utilizing this peel and the seeds, or you can say the kernels, in recovering the valuable products, then I may have a better utilization of the waste. That is one thing. And second, the way, the initial slide that I have mentioned, that devil's claw, okay, at the verge of extinction, this can be avoided, because we are not focusing on the main product, we are focusing on the waste that is generated. So over here, there is a probability in this, from fruit consumption to waste generated, there is a probability to utilize this peel and the seed as a resource or the raw material for these extractives, pectins or cellulose. Okay, so what can we achieve? The linear economy can be converted to a circular economy. So what is circular economy? It helps in a significant drop in the use of virgin material or the fresh material. Reduction in materials waste as products are designed to last, and utilization of manufacturing byproduct and excess material previously considered as waste stream. तो यहाँ पे क्या है? So over here, when we have this approach, the chemicals like this you can see carotenoids, essential oil, polyphenols, and pectin that can be extracted or separated or recovered from this waste. Also, what is left after this extraction can be utilized to produce thermal energy or electricity by converting them into a benchmark molecule, platform molecule. So, two chemicals out of this have been given a focus. One was polyphenol, another one was pectin. So polyphenols, these are, you might have heard about or in various advertisement also that word is popular, antioxidants, that the cream contains antioxidants, the food contains antioxidants, okay, the lotion contains antioxidants. So basically the antioxidants removes or stabilize the free radical within or there which are there in our body, and these are in good demand. So synthetic polyphenols are also available, but they are found to have a negative impact on the health. So there is a demand of naturally derived or naturally you can say formed polyphenols, and the demand you can see over here is in this tune 16.38 to 10 to the power 3 tons in 2015, and the market is of worth $1.33 billion. Pectin, another chemical which is used in say many you can say applications. One of them is in food application, wherein to prepare jam as a thickener it is used. Even the pectin, it is basically polysaccharide. Okay, it is used as a drug carrier also. So its demand is also very good, and you can see the market is of worth $1 billion. This is the structure of mangiferin. Mangiferin is also one of the polyphenol. Our target was to extract mangiferin from the waste, and this is a simple polyphenol, that is gallic acid. So the target we decided was to extract these two compounds. Now, as we know that we have very and varieties of mango fruits. So we have kept our focus on the Kesar variety, and the valuable compounds that were extracted uh, from the peels were using a conventional method and a novel method, emerging technique or a greener approach like microwave assisted extraction and ultrasound assisted extraction. So how to extract this, and what is the phenomena which is involved while extracting the material from the plant or the natural compound or the value added compound or the phytochemical from the plant. So this is you can say a standard structure, a generalized structure of the plant cell, wherein within this plant you can see the mangiferin polyphenols are present. So within the cell mangiferin is present, while this is the cell wall. In the cell wall you have the structure starting from say this middle lamella to plasma membrane. So within this structure a pectin is present between middle lamella and plasma membrane. So one product is available in the cell, while the another product is available on the cell wall. Okay, so what happens, to give you an idea how the extraction takes place. So basically there are 7 steps of mass transfer that occurs. So if we assume that this plant material or this cell, suppose this is surrounded by the solvent, Okay, this is surrounded by the solvent. So what happens that this surrounding will become your bulk. Around the cell wall, you will have a film form like this. A thin film will be the form over here. So what happens for extraction you require a solvent which has good ability, selectivity to dissolve the particular compound of interest. We call it a solute S. Okay, and solvent B. So what happens, this solvent which is available in the bulk will move towards the film. So the first step will be called bulk movement. Once it reaches this film, it moves through the film. So the movement will be over here. The movement will be over here. Just a minute, if I can get highlighter. Yes. So movement will be over here. So the second step will be movement through this film. It is called film diffusion. So your solvent has first moved through the bulk of the solvent, then it has moved through the film of the solvent, then it reaches the cell wall. Once it reaches the cell wall, it will move through the cell wall, which is called permeation. Once it moves through or passes through or permeates through the cell wall, it enters the cell, and then over here in the cell it will go for dissolution or solubilization of the compound S, mangiferin over here. Once the dissolution is over, once the solvent and the solute combination reaches the saturation, it travels back. So now after dissolution is over, again this process will start, and first it will move through the cell wall. So now the movement is in outward direction. Permeation, then there will be film diffusion, and after that film it will come out. So bulk. So this is how your extraction will take place. Okay, so what is happening? First you are dealing with the bulk movement. First you are dealing with the bulk movement. This bulk movement is considered to be a faster phenomena. Film considered as a laminar region or a stagnant region where the movement will be restricted, so it will be slow phenomena. Permeation, the movement of solvent will be through the solid material, capillary, porous structure is there, so this will also be a restricted or a slow phenomena. Dissolution, since we have selected a solvent which is able to dissolve the liquid in a better manner, this dissolution is considered to be a faster process. So this will also be a faster process. Once the dissolution is over, there will be backward movement. This bulk, film and permeation, the first three steps, these three steps were towards the cell. Dissolution has occurred within the cell. Now these three operations or the steps, permeation, fill and bulk, the last three steps, that will be away from the cell. So now your solution, initially these first three steps, it was only solvent. After dissolution it has become a solution. So this solution will now move outward. So first step is permeation. Again it is passing through the wall, so it is a time consuming process. Then a film, again a time consuming process, and the moment it reaches the bulk layer, it will move faster. So out of these 7 steps, 1 2 3 4 5 6 and 7, out of these 7 steps, 4 steps, film, permeation and fill, these are time consuming step, known as rate determining step, known as slowest steps, while the bulk, dissolution and bulk, they are faster. So when we go for the conventional operation, like we have kept the solid material into the beaker, and we have kept solvent into the beaker, and we have provided the agitation, then these are the steps you will observe. You can make it faster, the process you can make it faster by increasing the temperature, but still you will have an issue when the movement is through the cell wall. Okay, so this is the conventional way. And when we go for this conventional phenomena, the process time that is required to complete the operation, sometimes it is in hours and sometimes it is in days. Okay, so that is the limitation of the process. Also the process is time consuming, that means it requires good amount of energy in terms of electricity. If we are providing say heating, then it requires electricity for heating also. If it is vaporization happening, then we need to provide electricity so that there will be no vapor loss. So the moment time is increased, the related or associated utility requirement will go on increasing. If we focus on simply on say electricity requirement, so if the electricity requirement increases, it directly relates to the requirement over the thermal power plant. Now if we focus on the requirement based on say coal power plant, thermal coal based power plant, then what will happen? You require more electricity. That means to run or to produce that electricity through generator, you require to run the turbine for more period of time, for longer period of time. To run the turbine for longer period of time, you require more amount of steam. To produce more amount of steam, you require more load, or you can say more water, because you will produce steam in the boiler. So your water consumption has increased. Water consumption, from where you are taking water? From nearby water body. So your one utility requirement has increased. Now you are producing water, sorry, you are converting water to steam with the help of thermal energy. More water requirement, more steam requirement leads to more coal requirement. So your load on coal has also increased. So that is called fossil fuel consumption. Now during combustion, we are having generation of carbon dioxide. So we have increased carbon dioxide emission also, that is leading to say more or increased carbon footprint. So just by focusing on electricity requirement, we have traced back to the electricity, we have traced back to the fossil fuel requirement, water requirement. So a small change in the process by reducing the time. What you are trying to achieve by reducing the time, you are trying to reduce the electricity. The moment you are able to reduce the electricity, these are the advantages that you can get. The way I have explained the negative things, like I have reduced the time, so my electricity requirement reduced, my water requirement will get reduced, my coal requirement will get reduced, CO2 emission will get reduced. Okay, so this is how I can get the benefit if I'm able to simply focus on reducing the time. So how can I reduce the time? If I'm able to minimize the time taken by these steps, permeation and the film diffuser. So what are the alternatives available? So ultrasound assisted extraction. So over here, ultrasound, these are the waves. Okay, and in process industries, the range of the or the frequency of the ultrasound that is being used generally is from 20 to 50 kilohertz. Okay. So what happens when you induce the ultrasound in the medium, a liquid medium or any solvent medium, then what will happen? The wave will propagate like this. The wave will propagate like this. So when you are focusing on the upper cycle, it is compression. That means the molecules within the liquid will experience compression, and when it is rarefaction, this molecule will go apart. If you can visualize in you can say in childhood you might have thrown a stone into the water body lake, so the waves were getting generated. In a similar form, over here also the sinusoidal waves are getting generated, wherein the medium experiences continuous compression and rarefaction cycle, or compression and expansion cycle. So because of this continuous compression and expansion, the dissolved gases which are there in the liquid will come out in the form of bubble. And during this compression and rarefaction cycle, as you can see over here, the bubble will grow slowly. Bubble form, expand, compress, expand, and at one point of time, when the pressure within the bubble and outside pressure they mismatch, bubble will get collapse. If this bubble collapse is in the line with the solid material, then it will create, or even perpendicular also, then also it will create the microjets and the shock waves. Also, it will induce high micromixing or micromixing happening at molecular level, which will increase the heat and the mass transfer and sometimes the diffusion of species. In case of solid, what happens? This bubble collapse, when it is happening, it can damage the solid material also. How? I will explain it in next slide. This is one more slide showing the impact of the compression and expansion cycle, how the bubble is formed and then how a bubble is growing, and when it is ruptured. There is a hypothesis. Again, these values are not experimentally measured value. There is a hypothesis saying that during that particular rupture, temperature released is around 5000 degrees centigrade and the pressure release is around 1000 atmosphere. But the bulk temperature increment won't be that much high. Please remember this. This is not a measured value. What happens? So let us focus over here. So suppose this is your plant material, one part. Okay, so the bubble has grown near to this surface. So because of the bubble rupture, the energy released over here can cause the crack or the breakage of the material like this. Okay, and if it is occurring in the plane, so this is perpendicular to the plane. If it is occurring in the plane, then it can induce erosion also. So it can erode or induce crack within the plant material. This is one SAM which is shown that over a period of time, this is the intact you can say cell. Over here you can see the damage that has occurred due to the ultrasound impact. Now over here, now if I again explain that if this breakage is occurring over here, then it can damage the cell wall. So you can have fragmentation, you can have fragmentation of the cell wall. The moment you have fragmentation, broken cell wall, that means your solvent can easily enter the cell. Also, as I told you, your microjet phenomena will occur in the direction of the cell also. So erosion can happen. If erosion is happening, then whatever film that has formed over the surface, that film can also become the thickness of that film can also get reduced, or the film may diminish. That means both the issues that I have discussed, the film and permeation, can be avoided with the help of ultrasound treatment. Let us come down again. So if this is possible, then I may expect some improvement. I can expect some improvement in the process. So there is one study wherein the oil was extracted from the leaves of a plant material. So what was the advantage? This yellow one is a conventional process, while this green one is the novel or ultrasound based process. So what was the advantage? We have used the same, for comparison purpose, we have used same amount of plant material, same amount of solvent, and when we compare the outcome, you can see that the yield means how much amount of oil I have recovered. The yield requirement was almost 50% higher, 150 percentage. If 100 percentage hydrodistillation, if 100 percentage is the reference, then this was 146, around 150 percentage. So we have improved the recovery. That was one observation. Second, the time was reduced. For hydrodistillation, if it is 100 percentage, so in case of ultrasound, it is 57 percentage. The moment time got reduced, I need lesser power requirement. So power requirement was reduced and it is 24 percentage. The moment I need less power, there will be less carbon dioxide emission and it is 24. Since the time was reduced, I need less utility. So utility means cooling water requirement. It was also reduced. So by focusing on improving the extraction time, I was able to, or we were able to reduce the power consumption, carbon dioxide emission, and utility requirement. And what is the additional benefit? The yield was also got improved. So by incorporation of ultrasound into the process, there are high possibilities that I can have a better extraction. These are the two variants of the ultrasound process. This is called probe based, where the probe is directly inserted into the beaker and the ultrasound are generated through the probe and they are directly then passed through the material. So this is called a direct ultrasound impact. Over here in bath, generally, if this is the bottom, then over here the transducer are kept. The transducers generates the ultrasound. This ultrasound then enters over here. This bath is filled with a medium, generally water. This ultrasound then enters the water medium, and within this you will have a beaker. So first, through transducer, ultrasounds are getting generated. These ultrasound enters the bath water medium, and then they enter the beaker. Okay. So over here the introduction of ultrasound is not direct, it is indirect. But the advantage of this bath is you can have multiple units. So scalability is an advantage. Over here also, in case of probe also, you can go for sorry, you can go for uh, scaling up, but over there the probe requirement and you can say the power requirement may increase. That is one thing. Second, for acidic medium you need to be very careful by selecting a probe material because it can damage the probe. So this is your ultrasound unit. The another way of improving the process is through the microwave assisted extraction. So over here, in case of ultrasound, the effects were more mechanical. Well, in case of microwave, the effect will be by imparting a change in thermal energy. So that's why microwave as a source of heat. Okay, so how heat is generated through microwave? There are two principles. One, that is through ionic conduction, and another that is through dipole rotation. So in ionic conduction there is a movement of, okay, so microwave, they are basically electromagnetic waves, and generally we are using 2950 megahertz frequency of the microwave. Okay, so either it is ionic conduction or dipole rotation. So I will explain through dipole rotation. So what happens, this is the electric field, and for polar molecule we will have, this is positive side in the field, and over here this is negative polarity over here. So when the field is generated and fields are opposite, there will be an attraction, and since the field or waves are continuously moving, the moment there is a negative field over here, you can see the negative field over here, then the polar molecule will experience repulsion. So over here you will have attraction, over here you will have repulsion. So what will happen when these microwaves are passed through the medium, the polar molecule will try to realign itself based on the field, and the rate of realignment is very high, that is 4.9 10 to the power 9 times per second. So this is the speed with which the realignment of the molecule takes place. Now when this is happening, there are two things that we need to consider. One, how much effect, or you can say influence, of the microwave on the molecule is. For an example, if I am dealing with, say, non-polar, then there is no charge, so they remain unaffected. If I increase the polarity, then my molecule will get affected, but the movement will not be that much severe. So suppose this is the field, then, and so the movement will be like this only, like this only. Okay, so they are slightly affected. If my molecule is highly affected, then this can be the movement, vigorous movement. Okay, so depending upon the materials capacity to absorb microwave, your movement will occur. Okay, so first one is absorbance. Second, depending upon the weight, size of the molecule, this movement will convert the microwave energy into the thermal energy. Okay, so when we combine these two, we will have one factor called energy dissipation factor, and by understanding the information, or you can say this energy dissipation factor, this one, we can select a better solvent for an extraction. So what we know, how much microwaves are being absorbed, and from that absorbed microwave, how much is being converted to thermal energy. Okay, since water is the predominant component in biological material, and if we are utilizing water as a solvent in extraction, then its presence will directly enhance heating. The best example, if you have microwave at your home, then you can check, if you go for conventional heating and normal heating, within fraction of second you will find that the material is heated. Even the cooking, within fraction of second your food will be cooked, and the color in conventional cooking, color will fade. Over here, color will remain intact. Winter has just passed, so you may have prepared gajar ka halwa at your home. So there are two variants: one microwave cook, another say conventionally cook. So in both, you can say scenario, you will have different flavor, you will have say different you can say texture. Okay, so since water is present in all these you can say food material, the cooking becomes bit faster. And you might have observed that compared to conventional cooking, in microwave cooking the oil requirement is reduced, the water requirement is reduced. So indirectly over here also the solvent requirement may get reduced. Okay, so this is how the process takes place. Okay, so I have explained or I have compared the heating phenomena, the conventional heating. So this you can recall by simply heating or cooking your food over a gas stove. So what happens? You have kept your you can say vessel over the stove. So heat is first transferred to the vessel, and then the bottom of the vessel, and then it is getting transferred to the bulk. So always you will have very high temperature over the surface and lesser temperature within the bulk. This is how your surface heating takes place. While in case of microwave heating, we are using microwave transparent material. So heat won't be absorbed, or I should say microwave will not be absorbed by the vessel. They will directly be absorbed by the solvent at a molecular level. At a molecular level, high heat will get generated, known as localized superheating, and this heat will then dissipated outward. So you can find the temperature at molecular level very high compared to the bulk one, and these you might have experienced also, or you can check if you have microwave at your home. Just put a small cup of water in the microwave for say 10 second or 20 second, take it out and measure, be careful, measure the temperature over the surface and temperature within the bulk, somewhere around over here. So you may find over the surface the temperature will be bit less compared to the bulk. Okay, the reason heating is occurring at the molecular level, and it is known as volumetric heating. It is known as volumetric heating, and that is the reason why these microwaves are being used in reaction also. Just aside, you can say an additional information, if you recall Arrhenius constant, that is k equal to k0 e to the power minus e by rt, where temperature is very crucial and reaction occurs at molecular level. So at molecular level, since the temperature is very high, your rate of reaction is enhanced like anything. your rate of reaction, the movement is enhanced. That means your yield will be improved or conversion will be more, or more precisely, if your conversion is constant or yield is constant, then the reaction time will be reduced like anything. And in reaction chemistry, the study when involved a microwave, it is observed that the reaction time which was in hours or days is reduced to seconds or minutes. But you have to be very careful while utilizing microwave. Okay, one more thing just, and then we'll move further. The household microwave and the microwaves that are used in research laboratory or in industry, it is a bit different. Okay, so if you wish to utilize microwave for research purposes, don't utilize the microwave which is available at home, because it can't control the parameters. Please be careful while utilizing microwaves. Okay, so the same phenomena uh, in conventional, what happens, the conventional way, what happens, this is the direction of, this is the direction of thermal energy. Okay, over here the direction of the thermal energy is reversed. So in conventional heating it is from outside to in, outside in, while over here it is inside out. Okay, so when we go for the conventional way of operation, and when we go for microwave way of operation, as I have explained over here, the movement is from outside to inside, while in case of microwave it is reverse. So thermal energy, as you can see, is coming from inside to outside. The solute is also coming from inside to outside. So the movement of the heat, the movement of the oil is in the same direction. So both are moving in the same direction, causing synergism in the extraction, or you can say symbiotic effect in the extraction. In case of conventional, the movement is in opposite direction. So this arrow will be in opposite direction. So because of that, what has happened? These are the intact cell wall before extraction. So see, you can see these are the walls. Okay, these are the walls. And once the extraction was over, we have again checked, and you can see there is a severe damage. You can see the damage happens. So what has happened? The wall which was causing the, or you can say acting as a barrier, वो wall ही नहीं बची. The moment there is no wall, whatever material was there inside the cell has come out, and you can perform extraction bit faster. So what is the advantage? Say we have kept same solid loading. Now again the comparison is with the conventional method and the microwave. So when we have kept the same amount of solid loading, amount of material, and perform the operation, you can see first observation, the energy solvent requirement has reduced around 30%. Compared to 100, it is now 30. So 70% reduction has been observed. Yield, there is slight improvement. Your solvent requirement was reduced. Now let us focus on the time. Time is reduced to 22%. So around 80% reduction in the time was observed when microwave was selected. Since the time was reduced, your power consumption will get reduced, and the power consumption is reduced to almost half, 42%. Power consumption is reduced, leading to reduction in the carbon dioxide emission. So that is also reduced. So by incorporating microwave into the system, we were able to reduce the power consumption, carbon dioxide consumption, and solvent requirement, utility requirement, and the chemical requirement. One additional thing we have measured, that is the antibacterial activity. So the product that we are extracting, whether that product is able to perform its given task or not. So we generally measure antioxidant activity, activity, and this activity is then compared with the product that is extracted with the help of conventional method. So over here also we observe that there is an improvement in the antibacterial activity. So we have a waste that requires utilization. To improve the process, we have incorporated ultrasound and microwave. So now we have a process, we have a material. So let us go for the extraction. And over here we are having two products. So first one, when we have used the organic solvent, it is the case of sequential extraction. So what was done? The pills that were collected, then dried. We know that the increase in surface area will lead to improved mass transfer. So we have performed grinding. We have done sieving also, so that different size can be categorized and which size is better can be accommodated for the extraction. This plant material, after sorry, sieving, was then subjected to extraction. Microwave assisted extraction, ultrasound assisted extraction, and there is one more, that is combined microwave and ultrasound assisted extraction. Once the extraction is over, we have solid and liquid material, so went for filtration. The filtrate, the liquid one, was analyzed for mangiferin, how much mangiferin we extracted, and the solid material, the residue, was then subjected to pectin extraction. So this pectin extraction is generally done, was done with the conventional method wherein acid was used. So this extraction once done, again it was filtered. Solid material was not considered. The liquid material was considered for recovery of pectin, because solid material will have cellulosic compounds. So that liquid material, the filtrate, was then subjected to addition of ethanol for precipitation of pectin. After precipitation, again filtration was done, and the solid material which was retained over the filter was freeze dried, which was pectin. So the pectin and mangiferin were then analyzed with the help of analytical tool. So this is one way of extracting, wherein first mangiferin and then pectin was extracted, known as sequential extraction. This extraction was done with the help of organic solvent. Now there is another class of solvent known as hydrotroph, which can help in extracting the material in a simultaneous manner. These hydrotroph are having similar characteristic of surfactant, but they are more selective. Surfactants, they are non-selective. Hydrotroph, they dissolve everything. Depending upon the screening, and then you can have a better hydrotroph. So what was done over here? Again, same, raw material collected, dried, then grinding was done, sieving was done, then extraction was done. In previous case, organic solvent was added. Over here, hydrotropic solution was added. Hydrotrophs, mainly sodium salicylate, sodium cumin sulfonate, they are preferably used for the extraction purposes. For filtration, there was addition of ethanol. Addition of ethanol in the filtrate. Okay, so solid was not considered for further operation. That was the liquid which was considered. Upon addition of ethanol, the pectin got precipitated. So that pectin was then filtered and freeze dried, and the filtrate was checked for the mangiferin measurement. So we were getting pectin and mengiferin at the same time. Also, in this stage, what we did is the solid material which is left after the filter extraction, we checked whether the pectin remain in the solid material or not, or to check what is the efficacy of extracting pectin with the help of hydrotron. So we have measured that part also. So this is the ultrasound. Already I have explained how we have performed. So we have used the probe for the extraction purpose. And as you can see over here, this bubbles, when they rupture, they can damage the cell and your material can be extracted easily. Mengiferin and pectin can come out easily. This is how your operation look like. Okay. Up to this point, anyone having any doubt?
Hello.
Hello?
हाँ sir.
And till now, any doubt?
Participants, if you have any doubt, please ask to sir.
Okay. Okay, so let us move further then. So when I'm going for the extraction, I can't say fix the amount of plant material and amount of solvent that is required. What will be the parameter of ultrasound? I need to study all the parameter in detail. And after studying the parameter in detail, I need to optimize them. So once I select the process, the next step is to study the parameter and its optimization. So over here, the solvent that have been studied, they were methanol, water, aqueous methyl means the different percentages of methanol. These are the organic solvent. Then this sodium salicylate, sodium cumin sulfonate and paratoluene sulfonate. These are the hydrotopes that have been considered. So in extraction time, see, I need to provide enough time for the extraction. If I go for say shorter time, there are chances that complete extraction may not occur. If I provide longer time, then there are two possibilities. One, in longer time, my material is extracted, but now I am running the instrument without any additional advantage. So that may lead to additional energy consumption, additional time, one thing. Second, if these I'm performing at elevated temperature, then there are chances that the material which is dissolved now in the solution may degrade. Okay, so shorter time is also not preferable, longer time is also not preferable. I need to check what is the suitable time for this particular solute, for this particular plant material. That is one thing. Amplitude, that means suppose I am having an instrument, ultrasonic instrument having 500 watt. I can't supply 500 watt directly. The reason, the moment I supply this 500 watt, tremendous amount of thermal energy, which may not be suitable. Second, since these ultrasound are getting generated through intense vibration over a longer period of time, the probe may get back what is the best suitable amplitude, okay, for the particular system. So it was varied in the range of 80%. And the pulse time in case of ultrasound. Pulse is for how much time ultrasound will be in on mode and for how much time it will be in off mode. For an example, if I am running say ultrasound for say 30 seconds and if 20% is the pulse time, then 20% of the 30 second, that is 6 second, it will be in on mode, and the rest of the time it will be in off mode. If it is 80%, then for 24 second it will be in on mode, 6 second it will be in off mode. So this pulse will help to maintain, or you can say will help to utilize the probe for longer period of time. Then the concentration is also important. We know that with an increase in concentration, the solubilization capacity increases. So ideally higher concentration is desirable. But there is one drawback also. With an increase in concentration, the solution viscosity increases. The moment viscosity increases, the mass transfer characteristics are getting restricted. For a simple example to understand, if we take an example for Reynolds, so what we are doing, we are increasing the mu. The moment mu is increased, your Reynolds number is compromised. And we know that Reynolds number when compromised, it is going to affect my mass transfer, because Reynolds number is directly correlated with the Sherwood number, wherein we find the mass transfer coefficient. That is, you can say from equation point of view, or you can say analysis point of view, and from qualitative understanding point of view, higher the viscosity, more will be the resistance to flow. More will be the resistance to flow. That means my mass transfer is going to get restricted. So I need to know what is the best suitable concentration, because at one end, higher the concentration, more dissolution of the solute. But there is one more problem. If there is a limit of the solute in the material, then there is no need for increasing the concentration. Sometimes it is observed that on increasing the concentration, other compounds are also getting extracted. So we need to be a bit careful while selecting a suitable concentration. That's why that study is required. Then solid to liquid ratio. Again, how much amount of solid and how much amount of liquid should be there, because I need solid material under suspension. The material should not become viscous, sticky. Okay, because if the solid liquid ratio is limited, there are chances that all liquid is being absorbed by solid and there is no movement within the beaker or the extraction vessel. So you need to have a good amount of liquid, but excess amount is also not good. The reason, if you are increasing the amount of solvent, what will happen? You have increased the bulk. That means the energy requirement will be increased. That means the size of the vessel will get increased at no benefit. Okay, so you need to be, again over here, be careful that the amount should not be that much less that your solution become viscous, sticky, and it should not be too diluted so that your size of the vessel will has increased or will increase like anything. So these are the parameters that you need to study in detail. Once we have studied this parameter, we identify that these three parameters, pulse, concentration, and solid to liquid ratio, in case of hydrotropic extraction, and pulse, amplitude, and solid to liquid ratio in case of organic, they are important. So initially we have performed parametric study, one parameter at a time, and we understood how the process is being performed, how the parameters are being how parameters are affecting or have effect on the yield. Based on that, we have selected these three parameters as an important one, and we have selected the range also, okay, in which range they are having greater influence. So we have utilized this information and applied design of experiment, RSM technique, more precisely Box-Benken design, for optimizing the process parameter, wherein I can get the highest possible recovery of mangiferin, that is a valuable compound. So upon achieving, performing the study, we we were able to get around 9 milligram per gram of the mangiferin, wherein the pulse was 21%, concentration was 0.74, and solid to liquid ratio around 40 gram per gram. In case of methanol, amplitude again 21, the pulse was 30, and solid to liquid ratio was 25%. Over here, solid to liquid ratio was a bit higher. The reason was the salicylate solution or hydrotrophic solution is a bit viscous, so we need more solution, more amount over here. So if we look at only on mangiferin recovery, higher recovery was possible with the help of methanol. But when we focus on pectin, then scenario is a bit different. So whatever solid material and whatever liquid we have recovered, that was further utilized for pectin extraction. So the liquid hydrotrophic solution, when subjected to the pectin recovery, it was 11.85, around 12% pectin we were able to recover. And from the solid, when we have checked, still around 14% was there in the solid residue. So total pectin was 25%, out of which 11, around 12% was in the solution and 14% was in the solid material. Okay, while in case of organic, it was negligible amount, maximum was present in the pectin. So ultrasound was able to give us simultaneous extraction, but not full recovery. Even we have conducted the scalability study also, and we have scaled it up to 10 gram. Okay, and we were able to get good amount of yield. So we have tried the scalability study also. We have attempted the scalability study also. Then microwave. So as I have explained earlier, the mechanism of the microwave, heating will take place within the solution over here. Let me explain more precisely. So heating will take place. So whatever liquid is present over here will be converted into the vapor. So first your liquid is converted to vapor. Now we know that vapor requires more space compared to the liquid. So upon vaporization, this molecule will induce pressure towards the wall like this. Okay. Now if this heating continues and more vaporization continues, then there will be intense pressure towards the cell, and after a certain period of time, what will happen, your cell wall will not be able to hold that much pressure. Its yield strength will be achieved, and once it is achieved, the next step is the breakage. So this breakage, the moment this breakage occurs, your whatever material residing in the cell will come out. Okay, so this is what is going to happen in the microwave system. Again, as I explained, in case of ultrasound, over here also we need to study. So various parameters, so various solvents we have studied. Time, as I have explained, same you can say explanation holds over here. Temperature. Since microwave is temperature based phenomena, we can change the temperature. The moment we are changing the temperature, it is going to affect the vaporization effect on the cell wall. So temperature can be considered an important parameter. So generally higher temperature is desirable, and that we can see over here also, that 80 degree in case of hydrotrophic solution, and methanol, since it has reached around its boiling point, so 60 degree. How much power we are supplying to the system? More power means more intense heating. So higher power generally lead to vigorous microwave heating, vigorous rupture, and rapid extraction. But at the same time, If power is too much, it may damage or it may degrade or it may decompose the product. So again over here we need to check what is the suitable power. Concentration, as I explained in ultrasound, same theory holds over here, and solid to liquid ratio. So in all the cases we have, in all the parameters we have checked what is the effect. And if you have seen the values closely, then everywhere in case of ultrasound, the higher yield of mangiferin was observed in case of organic solvent. The moment we have utilized the microwave, you can see the amount extracted with the help of hydrodrop is higher compared to the utilization of methanol. Okay, so that is one change that we have observed. Again, we have screened out the best or most influential parameters in case of cumin sulfonate, in case of methanol, and perform optimization study. This you can see labels and the symbols with the help of box bank and design. Once optimization is performed, we got this optimum condition. Time was 5 minutes. Power we kept 80 watt. Concentration we got 0.6. Solid to liquid 1:45. And when it is methanol organic, solid to liquid 1:30. Why I'm focusing over here? Because over here in case of hydrodrop, solvent consumption will be a bit higher compared to methanol because of that viscosity issue. Time you can check in case of sodium cumin sulfonate, that is hydrodrop, it is around 5 minutes, while in case of aqueous methanol time is bit higher, 20 minutes. Power 80 watt, in case of organic solvent it is 111. So if you compare the results of hydrodrop and methanol, hydrodrop is giving promising outcome with higher yield also. Over here it is around 8.5, while over here it is around 10.5. This is what we got. Now we have gone one step ahead. Whatever material we got over here, whatever optimum conditions we got over here, we introduce the ultrasound. That means we kept, you can see the power, the power, let me, okay, the power, concentration and temperature and solid liquid ratio. These we kept constant. We introduced ultrasound power over here and studied how much recovery is possible in how much time. So what we observe that by introduction of ultrasound power, additional ultrasound along with the microwave, time is reduced to 1.5 minutes and yield is almost constant, 10.47 and 10.58, almost constant. Same if you focus over here, time is reduced to 10 minutes and yield is almost constant. Ultrasound we have introduced 50%. So when we combine the microwave and ultrasound, then also a promising result we were able to get. Okay, so that is an additional study that we have performed. So basically utilization of microwave has gave us a promising outcome, this one. Now let us focus on the pectin recovery because we are extracting pectin also. So after filtration, the liquid that was received was checked for pectin and it is seen that 25.38% pectin was present in the hydrotropic solution, while only 2% was left in the residue. So out of 27, we were able to get 25% recovery. And in case of aqueous methanol, it is lesser. So when we have used microwave for extraction of mangiferin and polyphenols, mangiferin and pectin with the help of hydrodrop, we were able to go for the simultaneous extraction. In case of ultrasound, Some amount of pectin got extracted, but not all. So we need that additional step. We have also assessed the antioxidant activity. That means after extraction, whatever material we are getting, is it able to perform the antioxidant activity or not? And we found that whether it is hydrotroph or aqueous methanol, whether it is ultrasound or microwave, it is comparable. It is comparable. So the activity is not getting affected. Okay, so this is what the outcome is. And based on this study, there are few things that we can take pride in it. We got patent, Indian patent. We had three publications based on this work and one conference publication. The other work which utilizes microwave and ultrasound and that being performed in our lab at SVNIT, that includes extraction of essential oil from the leaves of lemongrass, Pamarosa and Java citronella. These are called aromatic grass. Then oil extraction from turmeric, cloves and cinnamon. These come under spices. Essential oil extraction from the leaves of patchouli. Again, that was a CSIR sponsored project. This is a fragrant oil. Then oil extraction from leaves of mint. We generally use this mint in our can say tea making. Then pigment extraction from the beetroot and the flame of forest. And all are maybe aware about this water hyacinth menace, that aquatic plant, I should say aquatic weed, which is causing major issues in all the water bodies. So we have tried to utilize this water hyacinth for you can say extraction of useful compound. Okay, so these are the other works wherein the focus was on utilizing the waste or the biomass and utilizing this emerging technique. At the end, since the work was sponsored one, so we are thankful to the Anusandhan National Research Foundation, that is previously known as SERB, for financial support for the research work. So thank you. Thank you. So now if you have any query or you can say any doubt, you are welcome.
Hello.
Yes.
Uh, Dear participants, if you have any questions, please ask to sir. Okay. Uh, Thank you very much, sir. We are able to understand very important topic in these sessions, like transitions from linear economy to circular economy. Second one is the green approach in biorefinery, agro waste valorization, and understanding of microwave assisted extraction as well as ultrasound assisted extraction and their mechanism and parameter study, optimization with RSM, box Meghal design, and antioxidant activity. Thank you once again, sir, for giving your informative, knowledgeable session to our participants. I hope all the participants will be explore knowledge in their research work as well as future work. Thank you, sir.
Thank you. Thank you.